Good morning, everybody. My name is John Kowalski. I'm part of the marketing team here at Bic Gardner, and welcome to our web seminar on robotics, the Bic Mac Eye, Wave Scan, and Gloss. The presenter today will be Ray Roby, our business line manager for automotive. We are also recording this, and we'll make that available as well as the presentation materials available to you during our follow-ups, so stay tuned for that. Also, if you have any questions during the presentation, please enter them in the Q&A box located in the bottom right-hand corner of your screen, and we'll get to them following the presentation. So with that, I'll turn things over to you, Ray. There you go. Welcome, everyone.
Hello, everyone. So today we're going to talk about robotic Bic Mac wave scan and our gloss meter that's fairly new to the market. I wanted to start off with a video. Can everyone see the video? Or John, can you see it?
Looks like it may be coming up here. We'll give it another couple seconds to see gray on our end.
Gray? Now let me do it again.
All right. It'll work just fine 15 minutes ago. So here we go again, folks. There, now we're good.
Okay, so this just shows you, this is the company that we worked with, and it shows you basically how the instrument works. And I thought this would be easier than trying to explain it. So it's a short video, but give it a little time. So on the robot tool itself, there's actually a positioning system, which is really important to make sure that you get in the location correctly. And the Bic Mac gets positioned, and then there's like a foam foot on it that goes against the vehicle, and there's 4 pins in there that need to be pressed, but the pressure is very, very light. So it's not going to dent your part or injure your vehicle or anything. The other thing that's nice about it is both these instruments still work with Smart Chart, so it's the same exact format that you're used to with our other instruments. And that's the wave scan, which is non-touch. And again, you can go back into Smart Chart and look at the results. And the wave scan measures pretty fast. The Bic Mac takes a little bit of time, but we'll talk about the actual times in a minute. And here, this is all the stuff that you've probably seen before in Smart Chart where you can do trends over time. And that's the end of the video, so let me share my presentation now. Hopefully you can see the presentation.
Yes, we can.
Okay.
Yep, good to go.
Okay, so this is just a closer view of what you saw in the video. I have no idea why this is there. So here is what I was talking about, that foot that's on there that needs to touch. And then, like I said, the wave scan does not have anything. So this is all the specs on this. It does sparkling graininess just like our Bic Mac, and it measures exactly the same. So you could use handheld and the robotic in combination and be comfortable that your data is going to be the same. And the wave scan, like I talked about, the biggest thing is this is non-contact. You have to have a specific distance to the part. It's pretty tight tolerancing, but when you're using robotics, it's pretty easy for them to program and to get these different parameters correct. So when we use robotics, the basic idea of what you're trying to do is you want to make sure that you can measure as many vehicles as possible. And the other thing that's important is that it always measures the same location. So even when we really try with handhelds to measure exactly the same spot every time, we don't always get the exact same spot, and with the wave scan, you always do. So, and you can get more data or maybe measure more data points depending on what you're trying to accomplish. They're small and lightweight. I talked to you about the distance to the surface is important. It's 15 plus or minus 2 millimeters. You have to have the correct angle, and then your scan speeds can change from 500 or 50 to 150 millimeters per second. So everybody always asks me what the time is. So for the Big Mac Robotics, I told you there's the sensor that actually tells you how far away from the part you are. This takes about 4.5 seconds to get that correction in. And then when you rotate the tool to actually do the measurement, it takes 8.9 seconds to get in position. And then it's about 8.8 seconds for the measurement of the Big Mac, where you get the sparkle and the graininess. So the total time for the Big Mac is about 26 seconds. And this data is about 3 years old. And I think that they'd come out with some stuff that actually would make these times a little bit less. For the wave scan, it's about 9.8 seconds. And then to rotate the tool is 0.5 seconds. And then the measurement of wave scan is only 3.5 seconds. So the wave scan is a lot faster, and it's about 14 seconds for the total time. So when we look at robotics, what do we want to know? I know that we want to make sure that we have statistical process control. So this is important because when you're doing like corrections to your process, you want to make sure you're getting reliable data that you can control over time and make sure you're within that representative data that you want to get. It's good for system process analysis and optimization. So a lot of the companies, they use the wave scan data to actually go back in and make corrections to their process. It could be like a film build thing or something like that that's causing it, so there's really good ways for them to adjust all their process. You get the orange peel, the DOI, and all the customer scales, just like you do in the handheld. And also you can get the structure spectrum, which gives you detailed information about the quality. And again, I said before, it correlates really well to the handheld wave scans, so you can use all the data in conjunction with each other. So all the instruments measure the same, so this is important. The best thing about robotics is that you can get consistency. Here's a picture of an offline cell for a vehicle. So these cells, as you can see, there's a lot of safety measures around the outside. So I think the cost on these cells is between $500 and maybe $1 million, depending on how intricate you want them to be. They usually have 2 robots, so they can be the side and the other side at the same time. This just makes that process a little bit faster. And most people do about 32 points for wave scan and around 10 or 15 for the Big Mac. So we work with a lot of different integrators. ASUS is one that Germany works with a lot because they're out of Germany. We work with all the different robotics guys like AEB, Fanuc, Dura, Kuka, and those guys do most of the installation of the robots, and then you have the integrators come in and do the other work. There's a lot of different integrators in the U.S. that you could use. It just depends on who you want to work with. So here you can see in the picture that there's the Big Mac, the wave scan, and then there's the sensor that tells you how far away from the vehicle you are. And basically when you set these up, the robot guys are going to build the holder for you, like the head where the instrument's attached to. And also they will be the ones who decide which sensor system you use. And I think there's like 10 different types of sensors that you can use on the robot that will give you the positioning that you need to take the measurement. So another question that we get a lot is if you can use it on plastic parts. And here you can see an example of a fascia system. And the only thing that's really important for the fascia systems is that you have something behind it so that the ear or whatever you're pushing on isn't going to move when you set the instrument up against it. So here they have like full casts behind there that hold the part in place, and that's the way that they can get the instruments on the ears and in these different locations. Again, this is just another setup that you can do where they have a different sensor and a different head to the robot. So this one is an ultrasonic pre-positioning. I know there's different types, but for this example, it's an ultrasonic, and so that actually is what moves it into position to make sure you can get the reading that you need. So who's using them currently? We have a bunch of customers that are using the wave scan for sure. The Big Mac Eye, we're using at a lot of the OEMs and a lot of fascia houses in the U.S. and in Europe. So the Big Mac is a little bit different, I think, because it's a touch that some people, just don't want to have to deal with the touching of the Big Mac to their parts. But like I said, we've used it a lot of different places and we've never had a problem with it. So with the wave scan robotic, everything comes in a case, and also with the Big Mac, you get all the reference tiles and all the cables that you need, and the software and the installation kit and the operating manual. That all comes in the instrument. One thing that you have to make sure of with the robotic units is you always send the check tiles back in. Usually they hang them on the wall next to it, and then that's how it goes in and checks it. But then when they send it in for recertification, it needs to come in with the instrument itself, or we can't do the recertification. The other thing that we have is the microglass, and this microglass that's the robotic version is also exactly the same as our new microglass, and it also works with Smart Chart. You can have different modes where you do statistics or pass-fail or difference mode or continuous mode, and you can set up different check zones also for this. So the temperature stability is also important for the glossimeter. So just like our Big Mac and our wave scan, it's about 10 degrees Celsius to 40 degrees Celsius, and it's very stable over all these different temperatures. So this question comes up a lot because people are using the instruments in the plant, and a lot of times the plant floor can change drastically, even from the morning to the afternoon, depending on the weather outside. So for the automatic online gloss control, it basically measures like an XY table. So this one, your parts need to be fairly flat in order for you to be able to measure them. And it's not necessarily like a robot where it's twisting everywhere. It's kind of just going straight across whatever you're trying to measure. It does require contact with the surface. Just like our current glass meter, you need to make sure that that aperture is covered completely, or else you're going to get different glass measurements depending on how that instrument is not touching the surface correctly. With the glass meter, you also get the same thing, a carrying case, the glass meter fixture, which you can see is like the black piece underneath. And then there's 2 pins so that when the instrument goes in for the calibration or calibration check, it fits in there directly and you know that you're getting a good measurement. It also has the Smart Chart software. You can either get Smart Chart Lab or Smart Chart Process, depending on what you're doing, and the operation manual. And that's pretty much what I have for the presentation. Are there questions?
Yes, thank you, Ray. Great stuff, and we know that was, you know, an introduction. That's what this webinar was meant to be. If you have any questions, please enter them in the Q&A box located in the bottom right-hand corner of your screen. Also, if you have any comments or any challenges or you know, thoughts you have that relate to your own facility, we'd love to hear and help you out. Ray, are there typical questions that you get when a customer is, you know, starting to go down the robotics route?
The biggest thing is the cycle time that they talk about. So that one, like I said, it all depends on how the integration goes. So, sorry, I got a little bit of a congestion. So that's the biggest question that we get is like the cycle time. So a lot of people want to try to do inline also, where they're actually measuring like when the parts are moving. And we've got some customers that we might do some trials for that because they want to do it as fast as possible. But on most vehicles, especially the cars themselves, you have to have an offline cell. It's just too time consuming to take enough measurements. And on the fascia houses, all the ones that I've seen the setup, they're always in an offline cell too.
Okay, good to know, good to know. Other questions, comments? We're also looking to expand our web seminar offering. So in the next couple of weeks, look for additional topics. But today, another question came in. Will the WaveScan 3 be available in robotics?
At some time, it will be. But right now, we're still using the original one. A lot of the features of the WaveScan 3 aren't necessarily going to help with robotics application. So I don't think we're going to be changing it quite soon, but at some point it will become a WaveScan 3.
Okay, great. What are the biggest challenges that customers typically face when they're initiating a robotics program?
The biggest thing is the integration, because everybody does it slightly differently, and they may want something slightly different from the integrators. So that's the thing that varies the most. I mean, the robots themselves and the instruments themselves are pretty much the same, but the integration is usually about the most difficult.
Okay.
So
okay.
we just got another question about the profiler.
Yeah.
I don't think right now we have plans to make that robotic. Maybe in the future we will, but that's not something that we've even talked about up to this point.
Okay. Christine asked a question, and no worries if you were a little late, Christine. We're glad to have you. So she's asking, what's the difference between the manual wave scan and the robotic wave scan? Is that it just runs along the surface by itself? Maybe you can elaborate a little, right?
So basically the technology is very, very similar. The one thing, if you could hold the robotic wave scan at the correct distance and the correct angle, you could use a robotic wave scan as a handheld. But the reason the wheels are on there is to keep that spacing correct. So that's basically the only difference, is that the robotic's moving it and you're not moving it yourself.
Okay. Christine, I'm going to unmute you for a moment here. Did that answer your question? Are you there, Christine? Okay, maybe not. Another question in here, Gloss Robotics is only 60 degrees?
So, Sherilyn, unmute yourself. Are you saying it is only, or are you saying is it?
Having trouble with her audio.
So,
it's like, is that a question, Sherilyn? It is only 60 degrees.
It is only 60 degrees.
Okay.
That's what I thought you would say, but I wasn't sure.
Sure. Anyone from the field team, what other questions do you all typically get around robotics? Are there any particular ones that keep coming up for you all? Maybe Jim or Bob, I know you guys. Another one, what other instruments can be added to appearance measurements, film thickness, etc.?
So a lot of the OEMs and the add-on part guys put pelt on there too, but since it's not our instrument, I didn't want to show that picture of that. But yes, you can add
Sure.
film thickness. The robotic pelt, we now have a way to download it into Smart Chart. It's like a little, you have to take an extra step, but at least all the data goes into one location. We cannot, however, download the handheld pelt into the Smart Chart as of this time, but the robotic we can do.
Okay, great. If a customer doesn't have a particular integrator in mind or lined up, or someone they've been talking to, can we help facilitate that based on their needs?
Of course.
Okay.
We've worked with almost all the integrators, I think, in the US. And then, like I said, ASUS is usually used in Europe. And some of the robot guys, I think, are starting to go to where they want to do the integration themselves. So that would be another option if they actually get that far.
Good. Good. Are there, I know that the video you showed automotive and some larger parts, but are there smaller robots that can handle smaller parts?
So in the beginning, you could not get smaller robots because the bigger robots are a lot more able to move in the ways that you need it to move. But now they're coming out with some smaller robots that are actually pretty good. So for the future, I hope that's going to bring the cost down and also be able to be used on smaller parts and take up a smaller footprint. So I think that's important too. Because that's another thing, is, you know, where do you put this big cell? You saw how big the cell was.
Yeah.
It's pretty large, and, you know, the robots have to be able to move in there. So that takes up a lot of footprint in the shop to be able to have those big robots.
Mm-hmm. Do you see, another question, right? Do you see, due to the COVID going on in the country, do you see an increase in robotic use just due to keeping the social distancing, between people?
So not so much the use yet, but we've had a lot more increase for robotics than ever before because of the COVID. So
Okay.
I think it's something that's going to be much more widely used in the future because they don't want, like right now, if you're like on a automotive paint line, you're on the finesse deck or on the inspection deck, and you're actually running between people to get the measurements, and that's not going to fly anymore because they're not going to be able to be that close to someone else. So I think it's definitely something that's a big deal.
Yeah, definitely. Another question in here. How much data is typically gathered daily with the robotic system in comparison to manual data collection?
So if I am at a plant, like an OEM plant, they typically do at minimum one vehicle per model, per line, per color, per week. And with robotics, you could do many more. So like a lot of, like BMW is huge. They measure tons and tons of data. So they probably do 50 vehicles per week, different colors. It's just a lot easier. And it's safer for all the people who are, trying to run around the line trying to take these measurements. Because it's not really the most conducive atmosphere to be taking measurements with a handheld.
Yeah. With all that data go ahead. I was just going to say, with all that data being gathered, how is it, being used kind of across the board and within different departments?
So for the OEMs that use SQL servers, they can actually have their corporate people take a look at what's going on with the data, and there's so much more data. If you measure only one color per vehicle or per model, per line, per week, you really don't have or don't know what your process limitations are. So if you have more data, you can see if your process is fluctuating, if you're having like issues that only come up maybe on second shift and not first shift. There's a lot of things that you can do to monitor your process when you take more data. Like you can't control something if you don't know what's actually happening.
Mm-hmm. Yeah, very true. Very true. Just question, for me, a customer doesn't have any robotics. They don't know where to start. What guidance would you give them on a starting point and how should they, begin a program? What would your recommendation be?
So usually everybody has a favorite robotic supplier, and it's probably, like I would tell them that we could have a meeting with the robotic supplier and we could all sit down and discuss what we want to do so that everybody's on the same page. I mean, one of the biggest things is like what check zones do you want to measure and how many, because that's a big issue that affects your cycle time. So I know like we'd have some meetings and people start off with like all these check zones that they want to measure, and then they realize how much time it's going to take, and then they start to say, okay, maybe I don't need this many check zones, maybe I can get away with this, and that changes how the integrators are going to set it up. But like I said, we work with everybody, so usually the customer says, I want to use these robots or this integrator or something like that, and then that's how we start off. But we can always help if you need to get in contact with people.
Excellent. What other questions do people have? Just enter them in the Q&A box in the bottom right-hand corner of your screen. We'd love to help answer any questions at all. quiet crowd today.
Mm-hmm.
Anyone from our team have any frequent questions that they get from customers or any unique experiences that they'd like to share with the group?
John, Bob, I think Ray has pretty much covered the ones I get as far as cycle time, and it was the big thing. And of course, the initial cost is always a concern, and the space on the line. Difficult to work with this kind of stuff on an older plant, and hopefully the newer plants will accommodate things better.
Yeah, I think
so just,
a lot of the OEMs, when they're building newer plants, are at least setting aside the space for the cells, if not implementing them in with the initial build. But at least they're making space, which I think is a good thing for the future.
Okay.
And I can add to Bob's comment that we can always help with return on investment. You need something to put together for justification, we can help with that.
Excellent, excellent. How much downtime can be expected with a robotic system? Things like, cleaning adjustments, other troubleshooting issues?
So I can tell you that the first few robotic cells that we put in had some issues, especially with when the pelt was on there, because the pelt has to squirt water in order to take the measurement. And if the robotics head wasn't set up correctly, the water was actually going back into like the wave scan and causing it to corrode. And we didn't really realize what was happening for a while, but now we know that that can happen, so we've changed that. It's once you get it up and running and everything's set, there's pretty much no downtime. It goes out and it does its calibration, and then it goes and measures the parts, and it goes back and waits for the next vehicle to come in. So there's not a lot of problems once it's set up correctly.
Nice. And how often is certification needed? Annually?
Always annually, yes.
Okay. Another question here, who does the customer rely on for support? Is it, Bick Gardner, an external firm, integrator?
So
combination?
if it comes to the instruments themselves, it's us. If it comes to anything that's like actually happening with the robots, it would be the robot person. And if it's something with how the data is processed into the software, it would be the integrator. So it's a combination of all of it.
Okay, excellent. And in terms of training and setup, we assist with all that correctly, making sure staff's fully educated on the system.
We would help them with the data analysis portion of it, but there's really not much they have to do once it's up. They just collect the data or look at the data and use it for analysis. There's not a lot of setup. But if they never used Smart Chart before, then of course we would train them on Smart.
Excellent, excellent. It looks like we don't have any other questions in here. But like I said, we'll be sending the presentation out along with a link to the recording in the next day or so during our follow-ups. If there's anything specifically, we can assist with, Ray or any of our regional sales managers or technical specialists, we'd love to help. Don't hesitate to reach out. And thank you for joining us, and have a great rest of your Thursday.